linear equations. You guys did a lot of this in Algebra 1. So remember, an equation is a statement saying that two expressions are equal. Remember the general rule, what you do to one side, you must do to another. A linear equation is an algebraic equation in which each term is either a constant or a product of a constant in the first power of a single variable. So essentially, what that is saying is that we are only going to work with variables of the first power. So to solve an equation, the first thing you're going to want to do is apply the distributive property. Second thing, combine like terms. Finally, isolate the variable, get it on one side all by itself, undo the order of operations, and check your answer by substituting your result into the original equation and solve it. All right, so let's go on and just work through a couple of these examples. So in number 1, we have 12 equals 4n minus 10. So we're trying to solve for n here. So let's isolate n. Right now, we have 4n minus 10. So let's start by adding 10 to the other side. So we'll add 10, add 10. I've got 12 plus 10, which equals 22, equals 4n. Now, to get n all by itself, we need to get rid of our coefficient here. In order to get rid of a coefficient, let's divide. So divide by 4, divide by 4. And this will give us 22 over 4 equals n. We can simplify this fraction. Both 22 and 4 divide by 2. So this will give us n equals 22 divided by 2 is 11. 4 divided by 2 is 2. All right. We'll just stick to the left side for now. Please try the right side on your own, but we'll go over those together in class. So for number 3 here, like it says in the steps above, let's start by applying the distributive property. So let's distribute 3, and let's distribute negative 2. So 3 times 2a gives me 6a. 3 times 25 is 75. Negative 2 times a, is negative 2a. Negative 2 times negative 1 is positive 2. And that equals 78. Second, let's clean up by combining like terms. So let's take our 6a minus 2a, which gives me 4a. 75 plus 2 gives me 77, which that all equals 78. Now let's isolate our variable. So let's move 77 to the other side. We can do that by subtraction. So on the left side, I am left with just 4a equals 78 minus 77 is just 1. Now to solve for a, let's divide our coefficient. So let's divide both sides by 4. And that will give me a equals 1/4. Once again, if you were ever concerned about your answer and thought that it might be incorrect, feel free to substitute your answer back into your original equation. Okay, so in number 5 here, you'll notice that our coefficient on x is a fraction. So whenever you see that, think about that you're going to have to use the inverse property or a reciprocal. So to start, we have negative 3/4 x equals 15. So in order to undo our fraction, let's multiply by the inverse. Remember, the inverse is just when you flip your fraction. So let's multiply both sides by negative 4/3. Oh, let's try that again. Negative 4/3 and negative 4/3. So by doing this, essentially, our fractions cancel each other out, resulting in 1. So on my left side, I am left with just x equals 15 times negative 4 thirds. Remember, we can make 15 a fraction, 15 over 1. So we have 15 times negative 4, which is negative 60. 3 times 1, which is 3. Negative 60 divided by 3 simplifies to be negative 20. All right, and that's how you get rid of a fraction. Moving on to the second page here. Let's just do one more example with fractions, and then we'll go on to a couple special cases. So in our first example with fractions here, let's start by combining our like terms. So combining like terms for this one, let's just add our two fractions together. Remember, when adding fractions together, we must have a common denominator. So in order to get 1/2 and 1/3 to have a common denominator, let's multiply our 1/2 by 3 over 3. And let's multiply our 1/3 by 2 over 2. That way we can get a common denominator of 6. So multiplying these, I have 3 times 1, which is 3, over 3 times 2, which is 6, y, plus 2 times 1, which is 2, over 3 times 2, which is 6, y, equals 10. Remember, we didn't actually change our fractions here. They just look a little bit different. So let's combine our like terms. So 3, 6 plus 2, 6. Just add our numerators. That will give us 5, 6, y equals 10. And now we have a case just like on the last page. So from here, let's go ahead and multiply by the reciprocal. So I've got 6 fifths, 6 fifths. It helps you to see it. Make 10 into a fraction as well. Keep clicking on that on accident. All right, from here, our two fractions will cancel on the left side, leaving me with just y equals 10 times 6, which is 60, over 1 times 5, which is 5. 60 divided by 5 is just going to give me 12. So y equals 12. Once again, try number 8 on your own. It's a very similar process, but in number 8, you will have to subtract your fractions. So with the special cases, nothing is really too crazy for these. These are just cases where you may get infinite solutions, you may get no solutions, so on and so forth. So your steps stay the same. So for number 9, let's start by distributing. So let's distribute our 5 into both of our terms inside the parentheses. So 5 times x gives me 5x. 5 times negative 4 gives me negative 20. Plus 5x plus 12. So once again, at this point, let's isolate our variable. So the first thing I'm going to do is add 20 to both sides to get rid of this 20. So that would leave me with 5x equals 5x plus 32. At this point, let's get all of our x's to one side. So I am going to subtract 5x over to the left side. And that's going to leave me with 0 equals 32. So whenever you get rid of all your variables, that's when you have to start looking for infinite solutions, no solution, whatever the case is. 0 does not equal 32. We know that for sure. So in this case, we would have no solution. All right, let's try number 11 while we're at it. So in number 11, same deal here. Let's start by distributing our 2. So 2 times x gives me 2x. 2 times 4 gives me 8 equals negative 3x plus 8. Once again, let's isolate our variable. So let's start by subtracting 8 to the other side. This is going to leave me with 2x on my left side minus 3x. 8 minus 8 gives me 0, so just minus 3x. From here, if I wanted to get my variables to the same side, I could add 3x to the left side, which will leave me with 6x equals 0. Obviously, I'm going to solve all the way for x, so get rid of my coefficient by dividing. And x is going to equal 0 over 6, which is just 0. So this is one of those cases that x just equals 0 because our constants cancel out. All right, so hopefully what I went over in this lesson is review for all of you. I went through it pretty quickly, so feel free to pause the video at any point, work through the question on your own, and then check your work. All right, thanks for watching.